Guys, we're going to very quickly now look at heat transfer, which is how heat moves from one object to another. Remember, heat is energy that passes from an object at a higher temperature to an object at a lower temperature, and it's only called heat while it's in that process of being transferred. There are three different ways that this can happen. We can use conduction, convection, radiation. And be careful with those, particularly with the two C ones. It's very easy to get those confused. Let's start with conduction. Conduction is heat transfer that happens when two objects are touching. That is, the molecules of one substance actually have to be touching up against the molecules of another substance. And what happens is atoms have a certain amount of kinetic energy, and that's where their temperature comes from. And as the atoms of one substance bump into the atoms of another substance, they transfer that energy over. And so what happens is that as the atoms bump into each other, energy is transferred, so heat flows. And the closer the atoms of a substance are together, the better it will allow heat to flow through it. So we call those things where the atoms are very close together, they can bump into each other fast and move on. We call those things conductors. And if the atoms are very far apart, like they are in a gas, gases generally do not allow heat to flow very well by conduction, and so we call those insulators. So remember, conduction is heat transfer by touching. Convection is heat transfer by a fluid, and a fluid means it's either a liquid or a gas, can be either one. And what happens is that as the fluid is heated, that as energy is added to the fluid becomes less dense, and so it rises. And as it rises, it takes that energy with it. And so it moves the energy, it allows heat to flow from a lower position to a higher position. And we can kind of look at that with a graphic to get a better idea. So imagine you have a pot of water that you want to boil to, say, make a soup or something on the stove. So it's being heated from the bottom. This water that's in contact with the pot itself will be heated by conduction. That is, the water is touching the pot, so it will get warm by conduction. As the water gets warm, it becomes less dense, and things that are less dense float. So that hot water rises up to the top. You can see that arrow right there. And so that water rises to the top, carrying that energy with it, so it allows heat to flow from the bottom to the top. The really neat thing is that as it gets to the top, it cools off. It gives other atoms that energy, and as it cools off, it gets more dense and sinks back to the bottom, where it's heated again. And so you get this current, like a circular current from the top to the bottom, that we call a convection current. And this happens in the atmosphere. This is one of the main drivers of the way clouds work, is convection, where the surface of the earth is heated, air rises, cools, and then comes in a circular effect. Within the mantle of the earth, molten rocks do this as well. As they get closer to the core, they get warmer, become less dense, and rise, and you get these circular convection currents within the earth itself. Lastly, we have radiation. And radiation is energy that's given off as light. And this doesn't require matter between the two objects that the heat is transferring through for this to happen. So what happens is this, the hotter an object is, the more energy it's going to give off as radiation. Try and imagine the coil on a stove, that as you turn the temperature up on the stove and it gets really, really warm, that coil will start to glow red. That red light being given off is radiation. And all things radiate, so even people, for instance, are giving off radiation constantly. It's just that you're not able to see all the types of radiation. So the amount of energy being radiated determines the color of the light that's being given off. And we can take a look at that. This is what's called the electromagnetic spectrum, and this shows all the different colors of light that can be given off. Now we can only see as colors a very small sample of these. Purple is light with a lot of energy, so if you see something glowing blue or purple, don't touch it, very, very hot. If you see something glowing red, well, that's also hot, don't touch it, but not as much energy as up here. And what happens is that as things get more and more hot, they release more radiation towards this end of the scale. So this is the high energy end, this is the low energy end. And what happens is that things that are hot, say humans, we radiate in the infrared area of the spectrum. So we can't see it, it's just below what we can see. But we do give off this radiation constantly. That's what, when you see someone using night vision goggles and you can see people, even though it's very, very dark, the reason is that infrared radiation that's being given off. And anything that's warm will give off radiation like this. And you can sense this if you've ever been near a campfire. Imagine sitting beside a campfire and you can feel that warmth hitting you. Well, it's not from conduction. You're not touching the fire, I hope. It's not from convection, because convection will only carry the heat straight up. That heat you're feeling from the fire is from radiation. The fire is radiating energy, and your body is absorbing that and getting warm. So remember, 3 types of radiation, or 3 types of heat transfer rather. Conduction, which is when they touch. Convection, which happens in fluids where you have a current forms that carries the energy around. And radiation, where energy is given off as light.